Here is a Chapter 3 review, essentially. So these are practice problems from Chapter 3. The first Chapter 3 practice problems we'll do are based on the addition rule. So I wanted to kind of explain a little bit about why the addition rule is set up in this way. So if we're trying to figure out the probability, I'm just going to write it here. So don't write here, maybe off to the side. If we're trying to figure out the probability of some event A or some event B happening, we are going to add the probability of A plus the probability of B. But within each of those is the probability of each of them happening. So whenever we add those together, we have to subtract out the probability of A and B. And this is because in the probability of A, the probability of A happening would also happen if A and B were to happen, right? In the probability of B, the event B would happen if the probability A and B were to happen. So these are double counted. That outcome right there is double counted. So we have to subtract one of them out. So that is why the addition rule is set up in this formula here. So it's very important that you get used to using that formula. And hopefully that makes a little bit more sense about why we use it. So here we go. Here we have a math class of 30 students where 17 are boys and 13 are girls. On a unit test, 4 boys and 5 girls made an A grade, or they got an A on the test. If a student is chosen at random from the class, what is the probability of choosing a girl or an A student? So as soon as you see or, that is addition rule. Some event, a girl, or some other event, being an A student, is happening. So here, if we were to set this up, we have the probability of, instead of A, here I'll just go and write A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay? So we are asked, what is the probability of a girl, of choosing a girl or an A student? Okay, let me just move this over so it's kind of in the same setup here. So this part right here, this is our A, choosing a girl. So that's going to be the A. And I like to color code, obviously. Or B, event B would be choosing an A student. So B is the A student. So what we have to do here is we need to add, let me make this a little bit smaller. We need to add the probability of choosing a girl plus the probability of an A student, grade A, minus the probability of a girl and an A. So basically a girl who got an A on her test. Okay? So let me go ahead and highlight those. So the B's were all green here. Or an A student, A grade, right? So that's an A on the test. All right, so in this information here, it told us that 13 of the total of 30 students are girls. So the probability of a girl is 13 out of 30. The probability of an A student, it says that 4 boys and 5 girls made an A grade. So for this one, it is the probability of, so it's going to be 9 out of 30 total students are who made an A grade, okay? Minus the probability that it's a girl who has made an A grade. So the probability of a girl who's made an A grade is 4 out of 30 students. Sorry, not 4, 5. I'm sorry, I was looking at the wrong number. 5 girls, right here. 5 girls made an A grade, okay? So it's going to be 5 out of 30. So for this is going to tell us this answer here, okay? If we were to add 13 plus 9, we get 22 minus 5. This is going to be a 17 out of 30 chance that we get either a girl or a student who got an A on the test. Now again, the only reason why we subtracted this was because that 5 was counted here in the total number of girls, and the 5 girls who got an A was counted here. So that would have been double counting those two probabilities, a girl and an A student. So this answer is 17 out of 30. So here's another one. On New Year's Eve, the probability of a person having a car accident is 0.09. That's important information. So a car accident is 0.09. The probability of a person driving while intoxicated is 0.32. And the probability of a person having a car accident while intoxicated, gosh, never do that, is 0.15. What is the probability of a person driving while intoxicated or having a car accident? So driving while intoxicated or having a car accident. So let's just set up just the addition rule. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. The probability of A is driving while intoxicated. That's the first one. So what is the probability of driving, and I'm going to shorthand it, intoxicated, or accident, or having a car accident? Okay, so I'm going to write it like that just so I have a little bit more room here. All right. So I literally just wrote that exactly how it was worded here. I just shorthanded it. So the probability of driving while intoxicated or having a car accident. So driving while intoxicated, I'm going to use that color. So all of these A's are driving while intoxicated. The B, event B, is having an accident, a car accident, and that's the event B's. So here I need to do the probability of driving intoxicated. Sometimes I write it like that just to save room. Driving while intoxicated plus the probability of an accident minus the probability of intoxicated and accident. Okay. All right, so let me color code a little bit more here. So accident is green. Driving while intoxicated is orange. All right. So here we have the probability of driving intoxicated is 0.32. Okay. And the probability of having an accident, just in general on this New Year's Eve night, just having any car accident. Sorry, wait a minute. Having a car accident is 0.09, is right there. 0.09. Now the probability of having an accident while intoxicated, car accident while intoxicated, is 0.15. So this one combined is 0.15. Okay, so once, I'm so sorry guys, Macy is being pretty loud today while I'm trying to do all my videos. Okay, so once you add those together, so we have 0.32 plus 0.09 minus 0.15, you're going to get 0.26. Or if it was a multiple choice answer, you could say 26%. So that's a pretty high percentage, and that's really sad. So there's a 26% chance, according to this data, that somebody on New Year's Eve night will either be driving intoxicated or will be getting into a car accident. So that's quite the bummer. But that is the numbers for this problem. Okay, so that would be your answer. Alrighty, here's another one. Addition rule again. So the probability of a New York teenager owning a skateboard is 0.37. Again, as soon as I see info, I start underlining. Of owning a bicycle is 0.81. And of owning both a skateboard and bicycle is 0.36. If a New York teenager is chosen at random, what is the probability that the teenager owns a skateboard? So right here, a skateboard or a bicycle. Okay, so with that, I'm just going to move it over here again. I should just do that anyway. So with that, I'm going to write the actual probability formula up here. So probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. And sometimes that would be named as both, right? The probability of both of those two things happening. So again, I'm going to color code just because it kind of helps me see and it helps you see it. If we dictate skateboard as event A, okay, that's where skateboard will go. And the bicycle, owning a bicycle as event B. Okay, that's bicycle, bicycle, bicycle. All right. So here we have the probability of skateboard plus the probability of bicycle minus the probability of owning both of them. I'm just going to write the word both there. Okay, so we have bicycle and skateboard. All right. So I'm just going to go ahead and take a snippet of this guy here. Okay. Sorry if you guys can hear my neighbor's dogs barking. It's not my dogs, I swear. I don't know why they're barking up a storm. All right, so a skateboard is 0.37. Okay, so 0.37 plus the probability of a bicycle is 0.81 minus the probability of owning both is 0.36. Oops, sorry, I forgot to highlight the bicycle information right here. Okay, so now if we were to add that, so 0.37 plus 0.81 minus 0.36, okay? So this is going to equal 0.82. So there's an 82% chance that somebody either owns a skateboard or a bicycle, okay? An 82% chance that somebody owns either a skateboard or a bicycle. And that is it for that problem. Alrighty, so now we have expected value. So the first thing with expected value is you need to label the different sections of the spinner. So I know that this section with the $2 is 1/2 of the spinner. And then unfortunately, I wish this drawing had right angles, but they should have right angles here. So then that means that the $8 is 1/4 and the $12 is 1/4 as well. So I really like having them have the same denominator, and you don't always have to, it's okay. But 1/2, luckily that one's pretty simple to see, that I could also rewrite 1/2 as 2/4, right? If I multiply top and bottom by 2, then I can rewrite it as 2/4. So now the way that you set this up is you take the part of the circle, so 2/4 times its value, times 2, because that's worth $2 in there. And then you add another section, 1/4 times its value. This one is $8. And then again you add another section is 1/4 times its value is $12 here. And then what I recommend you do is put all of these values over 1, so then you can multiply the fractions straight across. So here, 2 times 2 is 4, 4 times 1 is 4, plus 1 times 8 is 8, 4 times 1 is 4, plus 1 times 12 is 12, 4 times 1 is 4. This one is super nice. So these all simplify. 4 divided by 4 is 1, 8 divided by 4 is 2, and 12 divided by 4 is 3. So whenever you add all those together, you get 6. So if you were to play this spinner, if you were to spin it over and over and over again for a bajillion times in a row, you are expected to win an average of $6 per game. So your expected value is 6, okay? I'm so sorry if you can hear Marley in the background attacking a fly. I think she just ate one. It's awesome. All right, here we go. Sally has a spinner game. Here are the rules of the game. The player pays $2 and spins the spinner. If the spinner lands on purple, the player wins 50 cents. If the spinner lands on yellow, the player wins $5. So let's see here. So let me sort this a little bit. So $2, if the spinner lands on purple, Okay, so I'm going to use my purple color. On the purple one, we get 50 cents. Okay, so 0.50 cents. That's how much we get. All right. If the spinner lands on yellow, the player wins $5. Wow, that's a much better one, right? We want to land on yellow. So this one would be $5. If the spinner lands on blue, the player wins $1. All right, so on blue, here we win $1. All right, if the spinner lands on red, the player wins nothing. So red is just $0. All right, so we need to find the expected value. And then we're going to think, okay, if the player has to pay $2 to play, is it even worth it? Right? So let's go and see what our expected value of winning per game is and go from there. First, we have to determine the fraction of each of the parts of the circle. So the 1 and the 8, so there's 8 total pieces. So that makes it super easy. They are equal pieces. So this one is 2/8 of the circle. The yellow one is also 2/8 of the circle. It's 2 sections out of 8. The blue one is 3/8 of the total circle. And the red one is 1/8 out of the total circle. So we're going to go and start setting up the expected value. I'll go and start off with purple. 2/8 of the circle, if we spun on either of those 8s, we would get 0.50, so 50 cents. Okay. For the yellow, if we were to spin on either of those 8s, 2/8 of the circle is worth $5. If we were to land on the blue, 3/8 of the blue is worth $1. And the red is 1/8 of the circle, and that's just worth $0, so nothing. So now if we go ahead and simplify this, again, let's go ahead and put a 1 underneath all of these. Honestly, guys, you could always change this to 1/2, but it's going to work out pretty nicely if you just keep it over 1, because then all the others will still be an 8. This one here, it's 0. That cancels out. 1/8 times 0 is 0, so we don't have to worry about that one. 2 times 1/2, or 2 times 0.5 is 1. 8 times 1 is 8. So basically 1/8 of the time we'll get 50 cents. 2/8, so go across, so 10. Oh no, I'm sorry, I misread that. Ignore what I just said about that. I am tired. 2 times 5 is 10. 8 times 1 is 8. Okay, that's a good amount. 3 times 1 is 3. 8 times 1 is 8. So if we add these together, we're going to have 14/8. Now, if you divide that, that'll tell you about how much money you would make per game. This would be $1.75. So if you played this game over and over again, your expected value is $1.75. So if you had to pay $2 to play each spin, would you want to play this game if you would only win an average of $1.75 per game? No, do not play a game. You would be losing 25 cents per game, right? If you only win an average of $1.75 per game after playing over and over again, your expected winnings is just $1.75. So paying $2, you'd be losing a quarter every game, okay? That would be the average. Okay, so here comes the trigonometry, all right? So we learned recently SOHCAHTOA. So the SO is sine equals, the sine of some angle equals opposite over hypotenuse. Cosine is equal to the adjacent over hypotenuse, and the tangent of some angle equals opposite over adjacent. So the first thing we need to do is label the focus angle. And these steps are in your lecture about trig ratio, so that's why I'm not writing out the steps again. So that's my focus angle. And then I always like to mark my opposite side right away. And then I notice that, so that this is my opposite side. And then I see that I have the adjacent side as well. And then this side over here is the hypotenuse, but we don't have anything on there. So another thing I like to encourage students to do is to circle the sides that they know, and those are the sides they're using in whichever ratio. So here we have the opposite and the adjacent. So we need to determine which of these ratios deals with opposite and adjacent. The only one there would be tangent. So we need to use the tangent ratio. So here we're going to go ahead and set up. So we have tangent of the focus angle, which our focus angle is 37 degrees. Tangent of 37 equals the ratio of opposite over adjacent. So the opposite side is x, the adjacent side is 15. So I would put tangent of 37 all over 1. Okay, and let me go ahead and put up my Desmos calculator here. There we go. All right, so I'm going to cross multiply. 1 times x is x. And then we have equals 15 times tangent of 37. So if I did that in my Desmos calculator, because that's the best one, 15 times tangent of 37 is equal to, x is about equal to 11.303. I'll just leave it at 11.3. Okay, it doesn't tell us if the side lengths are in feet or inches or centimeters, nothing like that. So we'll just leave it like that. All right, so same thing over here. My focus angle is the 28 degrees because that's what they gave me. So that's going to be my focus for this problem. And then my opposite is across from the 28. And then my adjacent is touching the focus and the right angle, just like the one was on number 6. So this one is the adjacent. And again, in this one, we don't have the hypotenuse, but I'm going to write which one it is anyway. This is the hypotenuse. But we are focusing on, for this ratio, opposite and adjacent. And that one would be tangent once again. Okay, so we have the tangent of the focus angle, 28, is equal to opposite over adjacent. So opposite is 12, adjacent is x. And you guys are going to see this one's a little bit different than the other one before. Okay, so here what we're going to do again is put the tangent of 28 over 1. I'm going to zoom in just a little bit so I can write a little bit smaller to save room. Okay. There we go. Move that guy up. Okay, perfect. All right, so now what we need to do is cross multiply. Okay. So I'm going to go ahead and take this. 1 times 12 is 12. X times tangent of 28 is x times tangent of 28. Now, we cannot just split off the tangent of 28. Tangent of 28 is a single number. That is a value. So in order to get the x by itself here, we need to undo this multiplication of x times tangent of 28 by dividing by the tangent of 28. Okay. So this right here, these two will cancel out. That's just equal to 1 dividing something by itself. So I'm left with x is about equal to 12 divided by the tangent of 28. And that is about 22.57 if I were to round it. The 8 bumps up that 6. Okay, so there's that one. So that one's a little bit different. You guys see there we had to divide because the x was on the adjacent side instead of on the opposite side. So it gave us a different way to solve for x there. All right, so let's keep on going. I think these are, oh yeah, we just have a few more, okay? All right, so here we have, I'm gonna zoom in again. So number 8, we have our focus angle here. So this is our focus angle. So across from the focus angle is x. that is the opposite side. And touching the focus angle and the right angle is the adjacent side, which is 15 here. And again, this one, since chapter 3 is only focused on tangent, you will do sine, cosine, and tangent in chapter 4. So that's why I'm teaching you to label all sides and then circle the ones that you plan to use for your ratio. So I plan to use the opposite and the adjacent side. Even though I have nothing on the hypotenuse side, those are the only sides I could use, right? But it's still important to recognize that. So here we're going to have, if you look at SOHCAHTOA, I just want to remind you why we're using tangent, because tangent is the only one with opposite and adjacent. So we have tangent of the focus angle of 42 degrees is equal to the opposite, which is x, over the adjacent, which is 15. So this one, you guys could just multiply both sides by 15 because 15 is on the bottom. But I always encourage you to cross multiply so that that becomes the natural thing for you to do. In case these two numbers were flipped here and you didn't realize that you couldn't just multiply both sides by the 15. So here, let's go ahead and cross multiply. We have 1 times x is x equal to 15 times tangent of 42. So if we do that in our calculator, we have 15 times the tangent of 42. We're going to get about 13.51. So x is about equal to 13.51. And that's our answer for that problem. Now if we slide on over here, let's go ahead and mark the focus angle is the 51 degrees. Okay, and then across from that we have 20, the side length of 20. This is the opposite side. Okay, and then we have the side length of x. This one is the adjacent because it touches both the right angle and the focus angle. So this one is adjacent. And again, we're only using tangent, so this one we don't know the hypotenuse, but we know that would have been the hypotenuse, right? That is the hypotenuse. We just don't know its value. But opposite and adjacent means we are using tangent. Okay? So opposite over adjacent. So the tangent of my focus angle is 51 degrees, is equal to my opposite is 20 over my adjacent, which is x. Now sometimes if you were to figure this out and kind of see the shortcut between this, anytime that the x is on the bottom, you can just switch these two and you'll end up with 20 over tangent of 51. So I'll show you why that always happens. So if I were to go ahead and cross multiply this like I have been doing, put that over 1. I'm going to cross multiply. 1 times 20 is 20 equals x times tangent of 51. Now I'm like, okay, well, I got to undo that multiplication right here between x times tangent of 51. I need to undo that. So to undo multiplication, I'm going to divide by tangent of 51. Remember, you can never separate those two because it is one number. The tangent of 51 is a single number, right? It's an ugly number. It's lots of decimals, but it is a number. So you cannot split them up. So tangent of 51 divided on both sides. Right here, tangent of 51 over tangent of 51 is just 1. So those two cancel out. So x is about equal to 20 divided by the tangent of 51, which in this case is about 16.2 if you were to round it. So these four were all about solving for a side in right triangles. And this one we really focused on tangent. That was the main focus. So you can assume that's the one you'll see on your test. Okay, so then here is the angle measurements. So we are needing to find the angle. Now we use inverse trig to find angles. This will not be on your test this week, but it will be on a test next week. So that's why I am including these in this video because it's super important. So we're still using SOHCAHTOA, but in this instance now, if we have sine, it's that the theta, the angle, is equal to the inverse sine, that -1. You would not say sine to the -1. You'd say inverse sine of opposite over hypotenuse. And then the cosine is theta equals the inverse cosine of adjacent over hypotenuse. And tangent, if you had the opposite and adjacent there, so that's why I'm saying is if we had these two, it would be this ratio. If we had these two, it would be that ratio. If we had these two, it's going to be this ratio. So it'll be the angle theta equals inverse tangent of opposite over adjacent. Okay, so that's what that one will be there. Alrighty, so these are relatively easy to set up. You still just do the focus and then draw your line across to the opposite side, opposite, and then mark your adjacent, touching the right angle and the focus angle. So opposite and adjacent is tangent once again. So here we're going to have that theta or the focus angle there. So if I were to use red, so theta is equal to the inverse tangent of opposite over adjacent. So our opposite is 12. Our adjacent is 8. So in Desmos, this is underneath the function option here. You should have the inverse of tangent button. So the inverse tangent of 12 divided by 8 is equal to about 56.31. So theta is about equal to 56.31 degrees because we're solving for that focus angle there. And you're done with that one. So really this one you have to mark everything correctly and then you will be just fine. So this is your focus angle. So I'm solving for theta. Let's see here. Across from the focus angle is my opposite side. So 9 is my opposite. And 6 is my adjacent because it touches both the focus and the right angle. So this one is the adjacent. So theta is equal to the inverse of tangent of my opposite. Opposite is 9 over my adjacent, which is 6. Okay? So if I were to plug this in, it's going to be the inverse tangent of 9 divided by 6. Which is again, wow, that's a coincidence there. So it's pretty much the same type of ratio. So here it is again. Theta is about equal to 56.31 degrees. That is a huge coincidence. I don't know if that was meant to happen on this worksheet. I didn't notice that. All right, so once again now, here we have number 12. I'll try to keep that up here so we can still see it. So this is the focus. We're solving for theta there. Across from the focus is the opposite side, 15. Touching both the focus and the right angle is the adjacent side, which here is 7, okay? So here again it is tangent. So my theta, or my focus angle, which is theta, is equal to the inverse tangent of my opposite over adjacent. So if I do my calculator, the inverse tangent of opposite over adjacent, I'm going to get 64.98 degrees. So my theta is about equal to 64.98 degrees. And that's it for that one. Okay, so for now, number 13, my focus angle is theta again. So that is my focus. So I'm solving for theta. And whenever I start marking, across from theta is the opposite side. So it's the 10 here. Touching both the both the right angle and the focus angle is the adjacent side. So that's the 14. So theta is equal to the inverse tangent of opposite over adjacent. So this one is 10 over 14. So if I were to plug that into my calculator, I'm going to get the inverse tangent of 10 divided by 14 is about 35.537. So I would round theta to 35.54 degrees. I always like rounding to the hundredths place. I just feel like it's most accurate. Simple. Okay, so that is it for the review. You also want to review multiplying binomials and a few other things as well. I remember were on the list for being ready for this Chapter 3 exam. So hopefully this helped you review the new terms and new lessons in Chapter 3. And make sure that you finish all of your Khan Academy to fully grasp all of the review that will also be on Chapter 3. Okay, email me if you have any questions. Thank you.